Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving zero array transformation 3. So we are given an integer array nums of length n and a 2D array queries where it has a left and right boundary, and each query will represent the following action on nums. So within the interval from left to right in queries, we will have to decrement the value at each index by at most 1, and the amount which the value is decremented can be chosen independently for each index. And a zero array is an array with all its elements equal to 0. And finally, we want to return the maximum number of elements that can be removed from queries such that nums can still be converted to a zero array using the remaining queries. If it is not possible to convert to a zero array, then we return -1. So if we look at this example, if we remove this one, it can still become a zero array because this can decrement these two by 1 and this can decrement these two to 0, so we wouldn't need this. And if we look at this example, we can remove this and it can still become a zero array because this interval can decrement these and this can decrement these. So all the numbers will be subtracted by 1 and that can make it a zero array. So the output is 2 because we can remove 2. And for this one, we return -1 because even if we don't remove any queries, it can still not make a zero array. So now that we have seen some examples, let's get to how we can solve this problem. I think this problem will be easier to understand when I walk through the example. So if the explanation is not very clear, make sure to watch the example walkthrough and maybe rewatch the explanation again later. So basically we will create a heap, and by the end of iterating through nums, all the elements left in the heap are all the elements that can be removed. And we will have a borders array where in the left border, we will increment by 1. In the right border plus 1, we will decrement it by 1. So it would tell us that right here, we can increment by 1. And then once we come to the right border, let's say this, for example, if we come to the right border, which would be 3 plus 1 right here, then we need to decrement by 1. So what happens is that when we come here, we can increment by 1 because everything has one operation done to it. But then when we come here, we need to delete it because it is no longer covering that window. So what we will do is we will iterate through nums, and whenever we come to an index where the left boundary matches the index that we are on, then we will add the right boundary to the heap. And if the number of operations ever happens to be less than the number that we are on, then we need to increase the number of operations. And then we also need to pop from the heap because that means that one cannot be removed. So we will pop from the heap and then edit the right boundary in borders. And if after doing these operations, the operation variables happens to be less than nums, then we can return -1 because that means we are not able to make a zero array. Otherwise, we'll return the length of the heap after iterating through nums. So yeah, let's go over this example real quick. So first, we're going to sort queries so they can be added to the heap in the right order. And now we look at the first number, we see that 0 is an index 0, so we will add the right border. And we also see that the number of operations we needed is less than num, so then that means we will need to use this query. So increase the operation and then we'll set the right border. After using this, we will pop it from the heap as we set the border. Now we come to nums of 1. We see that all these 3 are in index 1, so we will add them all. And by the way, we use the negative number because it's a min heap. So we add 3, 3, and 2. The operations 1 matches, so we can just move on. And 1 operation is still equal to 1, so we can move on. But now that we come to this number, right here it's a -1, so we add by that and operations now become 0 again. And as you can see, because this only covers up to here, so it's not covering this one. So now that operation is 0, we need to once again pop from the heap and edit the borders. So edit the borders and then we will pop from the heap. And now that we have come to the end of the array, we can return the length of the heap as the result, which is 2. So the time complexity would be O of n plus m log m, where n is the number of elements in nums and m is the number of elements in queries, because we will look through both nums and queries, but then we will have to sort the queries, so that's why it's m log m. And the space complexity would be O of n plus m, because borders will depend on the number of elements in nums and the heap will depend on the number of elements in queries, so that's why it's m plus m. And now let's get to the coding part. So first we're going to sort queries, and then we'll initialize heap to empty. We will initialize borders to 0 times the length of nums plus 1. And then we will initialize operations to 0. and q to 0. That's for the queries. And now we will look through nums. So for index and number and enumerate nums. So index will be the index in nums and num will be the actual number in nums. And then we will increase the operations by what's in borders. Now, if q is less than the length of queries and the left border is equal to the index we're on, then we will add the right border to the heap. So heap push, heap negative queries of q and 1, and we use negative because it's a min heap. And then we'll increment q by 1. And now if operations happens to be less than num, and there is heap, elements in a heap, and the first element in a heap is greater than or equal to the index we're on, then we can increment the operations by 1. And then we can also set the right border. So border is a heap hop, heap plus 1, then decrement that by 1. So that means we are using a query, so that's why. And if operations happens to be less than num at any point, then we can return -1 because that means we don't have enough queries to satisfy to make it a 0 array. Otherwise, we can return the length of the heap in the very end. Let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.